So now we take a look at another application of the Grignard reaction. And this Grignard application is a Grignard addition to nitriles. And this reaction lets us do a few things sort of very, very quickly. Nitriles can easily be made from SN2 reactions, among other ways to make them. And one of the most useful things about nitriles is what you can do with them once you form them. And so if we have a Grignard reagent such as this one, we can add a Grignard to it, and as a result, the nitrile goes away. But in addition to that, we form a new carbon-carbon bond, and we're left with a carbonyl that we can use to continue our synthesis. And so this reaction, is very useful because we can use it with a variety of different nitriles, as well as a variety of different Grignard reagents. So how does this reaction work? So if we start with our nitrile here, and this could be any nitrile, but in this case we're going to use the aromatic one. And to it, we're going to add methyl magnesium bromide. All right, so the first part of this mechanism is pretty straightforward. Just like with carbonyls, carbonyls being good electrophiles, you can add Grignards directly to carbonyls. You can do the same type of thing with a nitrile. And so your nucleophilic Grignard reagent will attack the carbon of the nitrile. And so in the first step of this mechanism, we've made our new carbon-carbon bond. At this point, the Grignard is done reacting, and we would go ahead and add our acid to quench the reaction. And then nitrogen anion will get protonated. So at this stage of the reaction, we've formed an imine. Now, an imine by itself is not necessarily that reactive under many sets of conditions, and certainly not under the set of conditions we have here. So to complete the reaction, that imine that we formed is going to protonate again from another equivalent of the acid. And so this forms an iminium ion, which is going to be a better electrophile for even a weak nucleophile, such as water, to be able to attack. And so this reaction, in many ways at this point, looks a lot like some of the other reactions of carbonyls that you may be familiar with, especially 1,2 type additions to aldehydes and ketones. Just this one is using an iminium ion as the electrophile. Once we've done that, we can get a proton transfer from oxygen over to nitrogen. That converts our nitrogen into a good leaving group. And then the alcohol that's now been formed adds in its lone pair, and it kicks out the leaving group, ammonia. Finally, one last step is to lose that extra proton off of the oxygen to form the product. And so you can see in a single reaction, we've added a new carbon group from the Grignard reagent. And in addition to that, we've left a carbonyl as the product. And so for synthesis purposes, it means not only have we made a new carbon-carbon bond, but that there's a lot more that we can do with the product going forward.